So, hello, my name is Zorz. I come from Slovenia. I work for Internet Society. And when I was discussing with Sergey about what to talk about, what they would like to hear, he said, talk about IPv6. And I said, okay, then let's talk about IPv6. Few of you have already seen these presentations. But for other people, bear with me. It's about 2 RIPE documents that we wrote in the course of all these years, and I would like to briefly speak about both of them. So the first one is RIPE 554 that superseded RIPE 501. Which one in the room is aware of this document titled IPv6 Troubleshooting for Help Desks using... No, 554 is about IPv6 requirements for ICT equipment. Who in the room knows about this document? Okay, oh, the usual suspects. Great. So this might be useful. Okay, a bit about me, very quickly. I'm a founder of Slovenian Go6 Institute. I worked in internet operations for 20 plus years. I'm not coming from academics part of the world. I'm more practical and technical. I have 16 years of IPv6 experience, well, now even more. And I'm an active and contributing member of RIPE and IETF communities and the primary co-author of RIPE 554 and 631 that we will hear later. I also wrote an RFC, and I joined the Internet Society in December 2012. And that's the picture. If you call me over Skype, you will see that's my lab. That's the place where we did those experiments that I will talk about tomorrow afternoon. Okay, first the warning. Despite the long contemplations, I could not find the way that I could avoid the walls of text. I'm presenting 2 documents here, so content is, the essence is the content of the document, and I could not find any way how to not do it. So we apologize for any inconvenience, but please bear with me anyway. So RIPE 554, what is it? That is a document that you can use during the equipment evaluation when you're doing the procurement process. So most of you are basically actually buying the equipment. So how do you request IPv6 capabilities? Basically, this is this document all about. It goes through the various versions of hardware and software and says what is the mandatory and optional RFC requirements for IPv6. But let me first tell you what it is and later on how it was made and adapted. People told me that they love this story, so I will tell it again. So RIPE 501, this was the predecessor of RIPE 554. It included 4 groups of hardware: host, switch, router, and firewall. And each section was divided in mandatory and optional sections, and also software IPv6 support was specified, and also the requirements for system integrators. If you are system integrators, in this and the previous document, there is a quite hard requirement for system integrators about IPv6 experience. Basically in 501 it was even harder and more brutal, basically, because we just included the form that the system integrators had to sign, that under some sort of responsibility, they assure that they have enough knowledge and experience in their team to deploy their hardware that they are selling in IPv6 networks. This is the new document. So after a year and a half of working on the first one, we were asked to publish a stable version of it, despite the fact that we knew there is some room for improvement. This document went through a RIPE IPv6 working group process of getting consensus from the technical community. So this is not something that we just wrote and published. This went through, I think, 10 cycles of editing and gathering comments from a RIPE IPv6 community. So I think we got a pretty good and solid consensus on the content of this document. So just a note, whenever you use it, it is completely neutral, because there was like 4,000 people looking at it. So if you're using it, if you use it in your procurement process, you can't, somebody can't tell that it is biased towards one vendor or another. It's not. It's completely neutral. So when we published RIPE 501, we had to promise to the community that we will immediately start working on the next version with improvements. So 1 year and a half later, RIPE 554 was published. And this is the table of content. As you see, we added some more equipment, like a CPU equipment, mobile devices, and load balancers. Declaration of IPv6 competence was a bit modified. And here, so for previous document, it was just Sander Stefan and me as the authors. Now we got Marika Kio, and she's a woman, and she brought a bit of nicer form of a document in, because previously in 501 we were two guys and we just mentioned a bunch of RFCs and be done with it. Now we got Marika in the team, and she made the document readable and understandable, and you know, how to use the document and all these explanations around. It got a bit longer, but hey. So this is for example requirements for host equipment. This is just one case. And there is mandatory support, and you see that you have all these RFCs specified. And if you specify this stuff in your procurement process, if the offered equipment does not satisfy all these mandatory requirements, then probably you should say that this offer is null and void and reject it and not buy the equipment. Then you need to be careful about the if. So, for example here, if support for tunneling and dual stack is required, then the device must support this stuff. So you have some options and room to choose which requirements you want to ask for. This is the example of optional section, and these are the goodies. And what we recommend in the document is that you say to the vendor or to the people who is selling you the equipment, if they fulfill the optional section, the more optional requirements they satisfy, more points they get at the procurement evaluation process at the end. So this is the incentive for the vendors to implement more and more optional goodies in IPv6, and they have been following this recommendation quite tightly in these years. So there is also a proposed generic text for the tender initiator, what to include every time. And this is very basic text that you should put in every tender. Like all ICT hardware as a subject to this tender must support both IPv4 and IPv6 protocols, and similar performance must be provided, and so on and so forth. You can read it by yourself if you find the document. So, how it all started? Why did we do this? Actually, I was sitting on a beer with the representative of our government, Slovenian government, in a bar, and we were chatting about IPv6 stuff, and I asked him, well, why you don't require IPv6 when you're buying equipment? And he said, because we don't know how to. And he said, can you please write me a text that we will include in the tenders, and then we will require IPv6 as a government when we will buy the IPv6 equipment. I said, okay, challenge accepted. So then this document, so there was like a week of thinking, week of writing, and then this document went through our Slovenian IPv6 working group, and then we had a Slovenian document. that was seen by Sander Stefan he's the RIPE address policy working group co-chair, and he said, well, you know, maybe this document would be also useful to other people. Why don't translate it and send it to IPv6 working group? And I said, okay, I will. So we did. And from there on, there was complete roller coaster. Sander joined me as the co-author, mainly because I was too lazy to fix the Google Translate errors, and said, Sander, you fix it and you can join as a co-author. And then the roller coaster started. There was lots of feedback from the RIPE community, what to do, what to move from mandatory to optional. So this is a pretty solid document. And what else? Yeah, on 24th November 2010, RIPE 501 was published, and then on 3rd of January 2011, on RIPE 501 bis started, and then June 2012, the result was published at RIPE 554. So it was basically 2.5 years of hard work put in this document, lots of community work, but I'm glad we did it. We just removed the speed bump from the companies that they did not know how to request IPv6. This is just an example of acknowledgements. There was many people from the community involved, provided feedback, so we put them all in the acknowledgements. So this got really good support from the community. Example of the discussion that we had in the community. For example, IPSec. So RFC 6434 changes IPSec must to should. So this is the IPv6 requirement for Node. And IPSec was mandatory, then it was optional, mandatory, should, must, and now it's should. So there was much debated topic to include it in mandatory or optional. In the end, IPSec was moved to optional section. So IPSec is not mandatory and not optional. Am I confusing you right now? Yes, completely. Okay. So we added the advice to the document. Organizations that use IPSec or expect to use it in the future should include the following in the mandatory section when initiating the tender. IPSec and so on. So why is IPSec a should? Because IETF figured out that there are devices like very small sensors, and Nigel may tell you about this. He is working with this, with very restricted hardware, that not the full stack can go into the memory. So if we say that IPSec is a must, we actually throw out all these sensor devices from IPv6 compatibility. So our advice is, if you are not buying sensors, then put IPSec as a must. And there was lots of discussion about this. What should we do and what not? And then we came with some Solomon solution. Adoption. Well, for example, there was a position paper written by our beloved vendor that starts with C. It is well hidden, so you cannot see which one is here in the URL. And they said that they, after careful analysis, they are expressing their support for the following reasons. That is very good. It is deployment oriented. It helps community to ask for IPv6, and it also helped them. So what they built is like a spreadsheet with all their products and RIPE 554 compatibility, and they're doing checks and crosses. So this also gave them the tool to improve their IPv6 adoption internally. But they said that they wanted to be more involved in the next version, so they were involved in 554. What else? Yeah, the European Commission developed the generic EU IPv6 profile, and RIPE 554 was the template for these requirements for your European Union. So it's currently in high demand all over the world, and many of the vendors are basically basing their IPv6 roadmap on this document. Again, it's very neutral. It was agreed by wide technical community, and it was consensus-driven, purely bottom-up process. Use it, it's free, it's yours. And here is the link, but I'm sure if you put RIPE 554 in the Google, it will lead you there. So what are the next steps? We are in the process of updating it, of course. It's been like 2 years now, or 3 years. We already got some suggestions and comments from the community. There are new RFCs. We found some bugs. We found some errors inside. But we have been told that changing the number, because people is used to it, is much pain. So we have pain of not updating it because the RFCs are not updated, and we have a pain of changing the number. So when the pain of not being updated is bigger than changing the number, then we will change it. But why you don't read it and suggest the improvements? Here is the email, 554b@go6.si. All the authors get the email. If you have any suggestions, we are collecting them. We have a GitHub problem collector. And when there will be enough suggestions for improvements, we will go ahead and change it. All right. This was the first one. How much time do I have? Okay. So we removed the first speed bump with 554 because people was asking how to buy the equipment. Now you know how to buy the equipment, and problem is gone. Then I'm traveling a lot around the world and talking to operators, and I heard from the discussion when I asked them why you are not deploying IPv6 to your residential customers, and many of them said because we are afraid that our help desk will burn down in flames if we enable it, because they don't know anything about IPv6. I said, but what do you mean, right? They said, we implemented IPv6 in the core, we implemented IPv6 in our services everywhere, but we are not rolling it out to the end customers. I said, look, on IPv6 World Day and IPv6 World Launch, the big guys like Time Warner Cable and Comcast, I know people who are leading IPv6 there, and I asked them specifically, what happened to the help desk when you enabled IPv6 for millions of customers? And they said, well, we checked, and there was more wrong number calls to the help desk than IPv6 questions. That means more people ordered pizza to their help desk than asked IPv6 question. So he said, what is your problem? But they said, you know, we cannot continue with the implementation if we don't tell our help desk what to do, but even we don't know exactly what to tell them. I said, okay, stop. Let's take care of this. And I put together a group of excellent people that actually deployed IPv6, and we started the IPv6 troubleshooting for residential help desks. So what is this all about? Okay, first, misconceptions and reality. During the process of this document writing, I heard a lot people saying, oh, that ISOC document about help desk is not an ISOC document. This is a community document. This is a RIPE document. And this is a product of a group of brilliant experts from the community. I just happen to be the initiator and one of the editors of the document. And I would like to thank ISOC for dedicating some of my working time to run this effort. That was precious. So, help desk. It's, you know, they can be difficult sometimes, especially if you ask them questions that they don't have answers. If you ask them questions that they can't answer or help people. So how to prevent this? There's a title, and the contributors and authors, as you can see, are like Lee Howard, John Jason Brozovsky, David Friedman, Jason Fessler from Yahoo, Tim Chown, Sander, Chris Grandeman, Jan Linkova, Chris, Daniel, and myself. There's lots of big operators from US here that actually deployed IPv6. Specifically Time Warner and Comcast, they have millions of IPv6 customers, millions. And their help desk, no problem. So, how did we tackle this? Fact number one, we need to build a short and simple set of detect, explain, action scenarios that would help people at help desk identify and fix the issue. Fact number two, for this we need an online tool to detect the state of connectivity. So, how many of you know test-ipv6.com? Okay, the usual suspects again. Yeah, you can try it here, but wait a minute. Don't clog the network yet. So test-ipv6.com is a very useful tool that detects the states of connectivity on the user's computer based on some JavaScripts and some magic and wizardry done by Jason Fessler. So I thought of talking Jason into creating a special version of this tool that was meant for ISP help desks only. And actually, well, Jason does not drink beer, so I had to bribe him with rum cola. So if we want to bribe Jason, he is drinking just rum cola. And he agreed, and he built the new version of this tool. And this is, so it's isp.testipv6.com. You can test it. And it's a bit different than the original one, as it says just much fewer information that is easily readable over the phone line. And there is a help desk code for most common situations. You see in blue? There. This one is 46T. That means that's dual stack and possible tunnel. I was testing this from, I think, RIPE meeting. Yeah. So what you do when your user calls in to your help desk, you tell him, can you please go and navigate with your browser to isp.testipv6.com and read me the help desk code. That's easy. And the user would go like and say 46T. And then the person on the help desk goes into our document and says, okay, what is this code? So here is a table of contents of this document that says it becomes very useful at number 5. That's IPv6 troubleshooting, the steps that you need to do. And then number 6 is explanation of help desk codes on this site. And as you see, we have here like IPv4 plus broken IPv6. This one is the hardest one, because if you have broken IPv6, you have no idea where it's broken, or on end machine, on a router, or somewhere in between. So this one was the hardest one. You will see the example. Then you have IPv4 only, IPv4 plus Teredo, IPv4 plus IPv6. Then you have dual stack with tunnel. You have 624. You have NAT 6.4. You have 46T. That's NAT 6.4 and possible tunnel. And then these are the most common errors, basically. And then you have additional things. It's like slow MTU and sites with failed connectivity. So if it's the MTU issue, we can detect the MTU issues. But this is probably not something that the first level help desk would have to tackle with. If there are MTU issues, probably they just forward and scale it to the next level and to the technical department. Then we have some IPv6 training for help desk recommendations for the manager of the help desk to say, okay, this is the training that your help desk guys need to and girls need to go through. And there is some operator specifics. And there is also the basic troubleshooting flowchart that Jan Linkova from Google did for us, and we put it in. And also some collecting data for escalation. This is one example. For example, 624 code. That's actually 624. And there are addresses. And then it's interpretation. 624 was used to provide, so this is what it is. Why do you see this error? And then you have action. So have user disable any automatic tunneling, and so on and so forth. And there is the whole procedure how to fix the problem. For example, this is 112, IPv4 plus broken IPv6, and there is a reason why we chose 112, because that's help. That's like, help. This one is very long, and there's interpretation that IPv6 network connectivity somewhere between the user and the website is broken. We don't know where, but you need to figure it out. And then it's action 1, 2, 3, 4, 5. Then it's like the list of addresses that should not appear on the end user computer at any point in time and things like this. So it's quite precise document with very concise instructions how to fix majority of the IPv6 issues that your users can have. So with this, I believe we also removed the next speed bump, so you don't have excuses anymore not to deploy IPv6 to your end customers because your help desk knows nothing about it. You just print out this one, add the specifics, and just forward it to your help desk and say, look, this is what you need to know about IPv6 because we are deploying it. If you get questions, use this document to troubleshoot it, and we are done with it. Check. Continue with the deployment. Very quick reminder, so this document became a first BCOP, that's Best Current Operational Practice document in the RIPE region. It was produced by BCOP Task Force and the IPv6 Working Group together. What is the Best Current Operational Practice? It's a living document that describes the best operational practice currently agreed on by subject matter experts. And I think if you're interested in developing these documents and documenting the current best current operational practices, you should also start your own activity here, like many other NOGs, or maybe join the BCOP Task Force activity at RIPE meetings. This is a bit of the activity that is going on around the world in documenting the best practices. There is a link if you want to know more. You go there or talk to me or to other people from this list. And what's the status and the future work? Oh, I have 2 minutes left. Perfect. I have another 50 slides.
Oh, you're fast enough to finish 50 slides for 2 minutes.
Okay, so you are adjusting time for me. Okay, thank you. So, okay, now document is now official RIPE BCOP document. It's called RIPE 631. Again, it's free, it's yours, use it. You can find it on the Google. There is also a link from RIPE NCC website. If you want to contribute in the best current operational practices development, join the mailing list and contribute to the discussion, or even better, start your own document of best current operational practices. And I've got still 1 minute, right? There is just a screenshot of the document, but you will probably find it yourself. What else? This is it. Questions? Thank you.
Okay.
Спасибо. I'd like to ask a question to the auditory. Who of you would try to use with the help of IPv6 our current connectivity? Please raise your hands. Did you like it? How did you like it? Are you ready to use it in your work? No one is ready. No one is ready. Okay, let's ask questions.
Will you do it in English or Russian? Okay, thank you. It works better if you turn it on.
BCOP.
Okay. I'm Pavel Lunin from San Jose, Moscow, Russia. I'd like to ask you about, so you told us quite a lot on IPv6 and the residential broadband markets. But what do you think on the IPv6 for business customers and IPv6 in the enterprise? I'd just like to know your opinion, because tomorrow I'll present on the enterprise networking, and I'd just like to know your opinion on what's happening to the IPv6 in the enterprise and in the business broadband. Thank you.
Thank you. So when we finished this RIPE 631, I went to the IPv6 community and to the BCOP community and asked, okay, we removed these speed bumps. What is your next problem? What do you want us to work on as a next document? And actually the response from the community was, can you please write a BCOP on how to deploy IPv6 at enterprise environments? People is completely confused about DHCPv6 versus stateless auto configuration versus that. And I think we already have the sort of like a table of content. We started with Sander. Again, it's very nice working with Sander. On the table of content on IPv6 deployment for enterprises, because enterprises are currently lacking the deployment, mainly due to not understanding too many options that are standardized for the address auto configuration, or they don't understand the security implications, so they're a bit scared about it. So they need help. We need to find a way how to uptake the IPv6 deployment in business companies. Now, when RN region ran out of IPv4 addresses, there is additional pressing on everybody to deploy IPv6, because sooner or later there will be websites that will not have IPv4 or will have IPv4 through some sort of translation. So if you want to, and enterprise environment is similar to ISP, just that ISP has a residential customers, and the enterprise environment, especially if it's big, has also their own users that just want to click the mouse and get the Facebook and Google and whatever they need. So we need to reach out more actively in this area and uptake the awareness of IPv6, because my personal opinion is that currently the enterprises, majority of them, is at the mental state that why do we need this, right? So we need to find the answer.
Соответственно, вы можете присоединиться к разработке соответствующего документа. As far as I remember, Jan is working on BCOP documents, and there is BCOP task force at RIPE. Task force?
Yes, and we have a table of content now.
So, as a representative of enterprise, you can ask your questions, you can make an addition, you can work together.
Yeah, if you would like to join, more than welcome.
Еще вопросы?
English, please, Dima. It works better. Did you switch it off?
It's not dual stack yet. So when I run the ISP test IPv6, it says my error code here is 4.6. Is that still bad?
I did not hear you.
The error code is 4.6 for this connectivity. So is it still bad?
It is. It's too bad. It's working.
Right. I just thought that it doesn't say error code. It says help desk code 4.6. So which code is okay? Is 4.6 okay on the ISP test?
Probably.
Okay, and then when it counts, it says testing 1 of 60, and then when it's done, it says tested 57 out of 57.
That's good.
Okay, so like the
so
three
you can reach the very small hidden transparent pixel on the 57 sites over IPv6 only.
Right. Okay.
Понятно. Давайте скажем большое